Rekil,
Nice.
you want to get started on the...
Yep, sorry. I was not able to join the first time. My bad. Cool. Let me start sharing my screen and let's start. Oops. Are you guys able to see my screen?
Not yet, but it's coming up, I think.
Yeah, I saw.
Cool, great.
Yeah, even I had difficulty getting in it. Kind of. Yeah, got it.
Okay. Cool. Yeah. Let me share a couple of things that I found and have a bunch of questions. So let's see. So just looking at the property decorator, basically, this is what the program is that link basically says that it gets a method to be accessed as an attribute. So basically, instead of calling it like with these method name followed by parentheses, you basically can do just dot method name. I have a few examples which kind of show used for attributes that are basically built from other attributes. We'll kind of understand what that means, and you guys can correct me if something wrong in my understanding there.
Yeah. So if just on that note, it took me a while to get the need or the understanding, and that thing that you just highlighted, I think, is one of the keys. And that is in Python, when one attribute changes, an other attribute that's dependent on it doesn't automatically change. But if it's a method, then when you change an attribute that's used in the method, then the result of the method changes.
Right.
So that's the reason why, first of all, that what you have highlighted is key to when the property decorator is used, because it's used when you want to create attribute which dynamically changes when you change some other attribute. Because methods in Python change when the underlying attributes change. But then now, why is it that this attribute can, that the property decorator allows that method now to be accessed as an attribute? Because previously that attribute might have been used by others and you don't want to change the usage. So it's this two-step linkage that makes properties a little tricky to understand. And it took me a while to get this aspect, that properties are things that hinge on other attributes which don't automatically change in Python.
And then in FastAI, I think you see a couple of instances where it's just used for convenience. So it doesn't fall under this regime at all. So yeah, quickly, let's look at a dummy example and then jump to FastAI. So yeah, you have your class person, you have first name, last name, and this full name is the one which is kind of derived from these other two attributes. So everything works sweet on this. We create your first name, last name. Everything is as we expect: first name, last name, full name. Email is the instance where it's a method which kind of derives from these two other attributes. So in this case, yeah, everything works straightforward and you get your outputs. Now, they give an instance where you decide to change the last name of the person. And this is what Srinivas is saying. So the fun fact about Python classes is if you change the value of an attribute inside a class, the other attributes that derived from the attribute you just changed won't automatically update. So what that means is that if you change this, let's say last or first, this guy full name which derives from that will not automatically change. Whereas this method which uses first and last name, that one will reflect the changes. And to see that in effect, you set person.last to be a new name, So person.last gets updated, but you see person.fullname will not get updated. And like we said, the method, which is person.email, that reflects the change. So if you want to incorporate this behavior, a simple change would be to make full name also a method like this guy. So to make that change is straightforward. You remove that self.fullname is equal to the first plus last, and you just write that in as a method like this. Now let's see if everything were to work. And going, so actually, yeah, if you make this change, self.last is equal to this new name. The one which broke was person.fullname last time. It didn't get updated, but now it does get updated. So we have the behavior that we want. But there's one problem now, and that is instead of calling, previously we were calling, because it was an attribute, full name was an attribute, we were just calling self.fullname, no parentheses. Now we've made this a method, so we had to add this parentheses in. So this is where, yeah, the example of if someone was using this API and they were using this as the call, now they have to change it to this, or else everything else will break. So this is where this property decorator comes into picture. Uh, you just create this method the way we previously did. Full name is just addition of these two first and last names, and you decorate it with the add property decorator. So now instead of calling person.fullname with parentheses, you end up just calling person.fullname. So you have this ability to update your name. At the same time, anyone who's using this code previously doesn't have to go ahead and update and make changes. So yeah, just to see all those changes. Can be changed now. So this is one part of like the property thing. Now the other problem is that now if you go ahead, this is kind of looking into what setters for this does. So if you go ahead and try to set person.fullname is equal to something, now since that was a method, basically it gives you an attribute error here. So this is where setters come into picture, and then setters kind of are defined when you want to kind of be able to set the value of this. And setter method should have the same name as the equivalent method that the property decorates. It accepts an argument. It accepts as arguments the value that the user sets to the property. You need to add the at method name dot setter decorator. So let's see this. This is the new part that we are going to be adding now. The rest of the function is the same, and this is the one we were dealing with, add property def full name first plus last. So first point for you to add is setter method should have the same name as the equivalent method that the property decorates. So that's where you kind of see the method is full name, and that is the same as this guy. It accepts as arguments the values that the user sets to the property. So you can make those changes that you're trying to make by adding this name in. Last time we started doing self.fullname is equal to whatever the name was, and that broke. So now you're accepting that value in here. And the third change that you need to make is you need to decorate this itself in this fashion. And that is method name is the one that we set. So full name and dot setter. So in terms of function name, what are the things, I mean, the method name, what are the things that you're using is that you create the same method name for your setter. And at the same time, you decorate it with the same method name dot setter. And now, yeah, you can take that in and then, yeah, just using split to set that up. And now, yeah, so you can even use that to make this change that last time broke without the setter, and all the pieces should work now. So that's kind of the dummy example over there. Let's kind of look at where all property is used, and you guys can tell me if, I mean, which instance it kind of falls into. So yeah, this is one place I think we use it in the data loaders. This is the one which basically just counts the number of different splits you have, basically the number of subsets. So usually this is going to be 2. You'll have your train val, or you can have your train val and test. And here, I think length of self-taught splits, your self-taught splits probably could change after you set it up. Maybe you want to make uh, 3 or 4 validation sets, and you want this to kind of update, I guess. So this is where your n subsets is kind of using this derived value being set from somewhere else. So I guess it kind of falls into that instance. So that is that guy. But yeah, let's quickly look at the other instances here.
Yeah, you have to look at it in the place where
Yeah.
it's used, I think, because
Yep.
self-dot splits, if it's defined in the init and stuff, and then subsequently you define n subsets, then you may want to do what you said, right?
Right. 1 second. Let me just kind of run this. Okay, cool. Let's look at that guy. That was the data loaders. Cool. Actually, yeah, this was one instance which I was not able to completely wrap my head around. So this is where you're setting, you're basically having the use of both what we saw now, property, and using the setter for it. Easy things that we saw was like, what are the things that need to kind of follow the convention for you to be able to do create both your property as well as your setter. And the instance where this kind of, I think in the use case would be like if you have a GPU, it automatically detects that you set it up. But for some instance, let's say you don't want to use the GPU and you want to forcefully make it use the CPU, then you could go ahead and set it to the CPU. So this kind of gives you the ability to set it to the CPU. If you didn't have this and you had only this, then again, you'd kind of get that attribute error, not having the ability to set it. Here, that first concept of using something as a derived stuff kind of doesn't seem to be the case here, I think. Or I don't know, maybe because self._device can probably change from CPU to GPU. So that's where it's kind of dynamic. So that's why you have the property here.
Where does the dot device
Yeah,
come
that is
from?
let's look at that. So that is what I kind of got lost with. So there are 3 of those 5 instances. Let's see where they start with. Don't care about that 2 device. So there are just these 3, I think, if I'm not wrong. Yeah. So there are just these 3 definitions that have it.
No, hang on. So
Yeah, I think you passed it. Yeah.
Just 2 actually. Sorry. Sorry, Tando.
I was like, I think you passed it, but you're on it now. Yeah.
Okay. So yeah, there's not. Let's see. So yeah, I'm still kind of confused about this one. If someone has any insight looking at this piece of code, this is where it's kind of being used. So this will be the instance where you're kind of setting it. So that I think kind of makes sense. You basically pass D, which is your device, that will be CPU or GPU, and you move all your data loaders basically to DL.2, whatever device you have set. And this kind of just updates self._device to D, which when you call this as the property data loaders.device, it'll basically send you back whether you're on the CPU or on the GPU. So
yes. So the other kind of use for property that I was thinking about that was there in the, I believe in the second link that I posted. I'm again, this welcome comments or thought, but I'm thinking that this is that usage, which is you have some attribute like say device, but you want some kind of check or some modification to it, and you want to control access to the device, and you want to do it through only the setters and the getters. And that's also the case where property is used, right? Like for example, the temperature example in one of the links that I provided says, okay, somebody has created a temperature property, but now you don't want a temperature attribute, but now subsequently you come in and you want to say temperature shouldn't be less than minus 373 or absolute value, whatever it is, right? Then you make it go through the setters and getters. So this, I'm thinking, is that kind of an example where the device could have been set somewhere, but he wants the device setting and retrieving to occur through the setters and getters.
Correct. Okay. So maybe, yeah, the device was set, and the thing that you need to forcefully kind of check is that all your data loaders are basically sitting on that same device. So like, if you guys look at the link that Srinivas has shared, where you have the temperature example that he's talking about, is you're forcefully checking that you cannot have temperature below 273, I think.
Yeah.
So you forcefully say that, okay, you cannot do that. And in this case, I think instead of you're forcefully just putting all the data loaders onto the device, they have to be onto the same device. Otherwise, yeah, you won't move stuff. So I guess, yeah, that is the example here. Though, yeah, I'm kind of still shaky on like when I would end up using it here. The other kind of easier ones that we have, we'll see while we're looking at like patch and stuff.
Again, on your question, again, a thought is if you're defined, if you don't, if you know that elsewhere the device could have been defined, and then you want to enforce a rule, like you said, somewhere else in your code, you need not care about what the other thing did, and you can just put this in though, right?
True, correct. Yeah, I guess I see that. Yeah,
Meaning,
instead
if
of
you're
every time
not
writing that
sure,
code, right?
right, then you could enforce it by just having it, because there's no other way that you can enforce it.
Other than, yeah, just rewriting code that again, like every time you do set that device, you basically move everything onto that device. But if you do it through the setter, then every time you set it, that gets called. So any forceful functionality that you want to do, you can write it below that, and that should take care of it.
Right.
I guess, yeah, that makes sense. Is anyone else having any thoughts on that?
Yeah, I would love to hear.
Yeah.
Where else? Yeah, right. This kind of our own conclusion.
Yeah, exactly. We're just rattling things off, which makes sense on the fly to us. But yeah, I think, yeah, that's kind of convincing to me. Okay, let's kind of look at what was the next.
But by the way, the one place I would check that is, the book you were referring, that Ramalho guy really explained things well. So it may be.
Yeah, I should have looked that. Yeah, I haven't reached that part yet. But yeah, I'll quickly actually look at that and kind of update you guys.
Influent Python.
Anything
He's good at
else?
those fundamental concepts, kind of.
Cool. Let's look at patch. Patch is the one which had me up last night because I was just not able to figure certain things out with patch. So get to some working code. Okay, here. So this is just the FastAI example, and image.image is basically nothing but that comes from PIL image. So let's quickly look at that. So oops. So yeah, so basically this represents an image object to create. Basically it's coming from PIL image.image. That's what image.image is. So now here, actually, yeah. So we'll again look back at property. At the same time, we'll kind of look at what the functionality of patch here is also. So now what is the usual kind of problem that you kind of face with PIL image is that to get back your height and width, in this instance, he's created two properties where you get it like return self.size 0, or else I keep finding myself doing this image.size of 0 to get the width and self.size. Image.size.1 to get the height. So this kind of this is, I think, the ease of use of the ease instance where you want to use property, where you kind of just create this function method rather, and now you can just reference this with like image.width, and you should get this back. I don't see, I don't know why this can't be used from a patch instance. The only thing is that patch, I guess, is like monkey patching. So it's kind of like, oh, we finished building this. We forgot to put this in probably here at that point of time. So later on, somewhere in code, you can go ahead and do that. So you can kind of achieve this functionality to both those things. He's set up even other things like aspect. So aspect ratio is something which is not calculated automatically there. He's added that in, and basically, so now you can access it as image.aspect. So image.aspect will be nothing but size 0 by size 1, or I think because you have width and height already there, you can just do W by H. So that's how that works. And just to kind of the ease of this, like in terms of using it, is I just go ahead and create this decorator is all you got to use at patch. You want this to be a property. And so I just create the same thing. I just call it aspect new. X is equal to this. You annotate the type and you return this. Yes, when I was kind of looking at the code, I realized that this really is very important. You need to specify what the annotation is, because if you remember from the code, the whatever first parameter you pass in, actually, where is the code?
Yeah, because patch is a type annotator patch.
Right.
Patch 2 is the patching it
No,
to the right, or other way.
Actually, the weird thing is, you know what? Never mind the underscore n. Basically, this just that is something that I called new. This is what patch 2 is, and this is what patch is. And you basically call patch, something happens, and then you end up calling patch 2 in the end of it. And basically, at the end of the day, this is the one that gets called.
Right, but exactly to your point, the reason you have to pass it is because patch n, I mean, whatever the equivalent, right, in his in the that notebook we saw is patch relies on patch 2, but patch 2 doesn't use the annotation. It just patches the class, patches the method to the class, but patch checks the type annotation. That's what we saw even in the notebook.
I see. Okay.
Okay. So that's why when you use patch, you must supply, as you highlighted, the image.image, because it depends on the annotation that you pass in.
Okay.
If you go to the notebook,
right here itself, you can see that part. The thing is that a class which holds the annotation is the first parameter that actually goes into this class.
Correct.
So this class can be thought of as basically the annotation that you're trying to add to or patch to. And we look at that piece of code, which will make more sense that time. But just to quickly give you an overview of what we're looking at. Okay, so that is the one which was with the as property. So property, basically, you don't have to end up with your parentheses when you call this. That's why you like add aspect new. I mean,
as an attribute.
Now, I was just playing around with this. I don't know. Like I said, I think the only instance where you would not do this in this case is. Oh, are you guys still able to hear me?
Yes,
okay.
I can.
Cool. So this is again, instead of using width as setting that up instead of the property, just kind of using it as in the case of a patch, setting up width new, returning the exact same thing, setting this decorator and setting as properties true, same functionality. these are the couple of other things that he uses. Add property, add. Okay, let's look at this piece of code and figure out what is going on. Let's do let's do this one first, because this is the one which at least kind of makes sense. Okay, so we are setting reshape new is what we want to add to image.image. This is the new kind of attribute that you're trying to throw in so that you can reshape it on the fly. So yeah, the key thing was, like we spoke about just now, is that you need this type annotation. And when this decorator is used, you basically jump in here, and F is going to be nothing but image.image, right? This is false, we don't care. You come down, if F is none, so F is not none, it won't go in there, you'll end up here. What this does is basically it's doing F __ annotation. So that's basically saying what the values, that's pulling out the annotations, and this is dictionary. And you end up basically pulling the value. Actually, yeah, let's run this code and see. Oh, that will make more sense. Cool. So we basically jumped here right now. So let's look at that. Okay, so this is where we are. If F is none, so F is not none. Let's look at that. F is reshape.new, that is this. We are not going to enter that. So let's move on. Wait, so CLS, let's look at this. This is not yet defined. So let's jump to the next line. So we'll kind of run through that. And let's quickly look at what this f.annotations is. So this should be a dictionary with what the variable is and what the annotation for that is. So it's supposed to be at PIL image.image. So this, if you do dot values, will basically grab, this is the key, this is the value. So class should finally be PIL image.this. And then we'll actually ship it off to patch.n. Let's do set, or should I? Sorry, I should run one more. So that's where classes got set. And now we'll kind of ship it off to patch2. So that's where those pieces kind of work. Let me kind of break this guy. I forgot to set this debugger. So let's do that. Sorry, I kind of saw what happened here. Okay. Okay, so we finished this. We kind of shipped this F function off, which was reshape to patch2n. We already know what class is, which is PIL image.image. As property just gets carried through, and we didn't set any of these. So these are like false and false by default. So we jump here. Now all this is doing is basically you want to run this for loop on this first value that you're passing in, and he wants to use it so that you can pass in multiple classes, or even if you have a single class, it should handle it. So all you're trying to do is just convert this to a list. So that's all, or a tuple, so that you can, or an iterator basically, so that you can iterate over. Then we looked at this nf.copyfunc of f. We'll see why we can't do this. Just do nf is equal to f. And this func tools update wrapper, this is basically a tuple of these guys. Module name, qual name, doc. Actually, I printed this out, so that should make life a little more easy. So let's look at that guy. Sorry, I'll be continuously kind of breaking these because something will just easier if you just print and see. So yeah, this is what happens. So reshape, remember reshape new is the guy that comes in here. Reshape new is the guy that comes in through this F, right? Class is nothing but your PIL image.image. So NF is basically copy func of F, where F is this new image, reshape new, sorry. And NF is the new function, which is a copy of that. So the copy thing in essence is any changes made to NF will not affect F, or any changes made to F will not affect NF. They're completely independent identities. And that's what you're trying to achieve with that. So you run through this, and you're basically setting for this new function that you're trying to create, you're setting these O's are basically going to be these names. So you're saying set attribute for this object, class, these values, these names. And what are the values that you want to set for them is basically through this get attra of F0. And get attra is what we saw here. So all it's going to do is NF is going to get these names, NF module, NF name, NF call name, NF doc, NF annotations with these values. So this key value, this dictionary is kind of what you're kind of updating there. So we looked at that, and now let's quickly look at one change, why this is required. Where did I do that? Actually, yeah, this is the line which requires that guy, or else this will break.
Kind of, he mentioned this in the video, and it's kind of an understanding of the decorators too. You could, I mean, it's not related to the copy and copy, but you could do the func tools update wrapper assignments is basically what @wraps does, because it takes the attribute from the wrapped and shifts it up to the wrapper.
I see. Okay. So that's the
@wraps.
I see. Okay.
But inside of @wraps is this wrapper assignment.
Okay.
So if you chase it down in Python documentation, that's what you'll find.
I see. Okay. Cool. So this is the case where things will break, is that you're doing NF is equal to F. So now when we come down here, NF.callName, and you're setting this up. So if you look at F, what is the best way to look at this? If we break. So NF basically.
Like it has a call name now. Scroll to the end.
Oops.
I saw call name.
Oh, okay. Okay, yeah. Actually,
yeah,
you're right. Sorry, I can do it that way itself, right? Let me just call it. So yeah, so F was basically reshape new, right? Now, since we did not make a copy of it, we ended changing NF, which was NF of call name. We said do C name. This is basically image. This is coming from that PIL image part of it. And the F dot name is basically coming from whatever your function name was that you passed in, which was reshape new. The intention of this was you wanted to change only this NF, but since you didn't make a copy of it, you ended up changing both of that. And that's what you can see now. We've printed up f.callName, and you can see that got changed. Now we'll do the same thing, but we'll do it with we'll do it the right way. So we update only what we require. Okay. Cool. And now if we do f__call name, this should just be reshape.new. This is what we expected. Whereas NF dot is the guy which you wanted to update, and that became image.reshape.new, which makes sense, right? The whole objective of doing this patch was you wanted to add this functionality to image, and that's what this call name kind of does the update with. So moving ahead from there, if class method, we won't be entering into that because that has been set to false. Now you again get back to set attra. Set attra is basically looking at the C underscore, which is going to be image. F dot name is your reshape.new. So you're saying for this object, sorry, for that class, set this attribute name. And what is the value you want to set is that if as prop, in this case, that is also false. So it won't be that, it'll just be NF. So you ended up adding this reshape new to image. And now you can access it as a method. So let's jump out of this guy. Let's quickly, where's my PDB? Okay. So now everything should be fine. And now, see, so you can end up using something like image.reshape underscore new 100, 100. So now you're able to resize your image to this. So this is the one, just to kind of reiterate, this is the instance where we are not setting prop is equal to true, as prop is equal to true. So let's look at the instance where as prop is equal to 2 is being done. This one, I need some help because I kind of got lost here. Let's again. Okay, first let me show you.
Before
Yep, yeah, sure, sorry.
I have a question. What exactly this method type class does, or whatever it is?
Oh, this CLS?
No. I mean this in this line, yeah, method type.
Oh, this method type. Actually, good point. We never looked at this because, in our case, it never went in here. I'm not sure what it does.
It's defined in the notebook. I forget.
Says here. So I think that is to create a bound instance method object. It says.
Yeah, so it's a instance method, and that whole thing it creates. If you NF as a method of F, and in order to do that, you need to, and this is a whole topic by itself. How do functions get bound to classes? And he does the binding here. The whole binding functions to classes thing is a topic that I wanted to dive into, but I haven't done it yet, so I can't explain that. But that's what he's doing there.
How is that difference from this case? Like if as prop was not set, right? So you're not doing property NF and you're not attaching that. You're basically attaching NF. And isn't this, if you're accessing it as image.reshape new, is this not a method instance?
Yeah, you're like setting it as a class method, not just a normal method.
Oh, as a class method there. Okay.
Yeah, method type is like an internal, is a Python function.
Oh, I see. Okay.
Yeah.
Okay. Oh, so it's like property. In the case of property, where you're making it a property, method type you're saying is where you're making it a class method. I see. Okay.
Yeah, I was just interested to see the source code. Where is it? A Python thing?
Yeah, it's a Python thing. It's a Python thing.
Okay.
Yeah.
Oh, I'm sorry. I cannot help you with that window. Yeah, I'm sorry, Arto. Yeah, so.
It's a Python. You can just go to the.
Cool. Yeah, okay. Sounds good.
Rikal, just a question on. We are like with the patch n. We are doing the monkey patching. Is that correct?
Yep.
So why we are doing a patch underscore n and patch underscore 2n?
Oh, sorry. That's like I said, don't mind the underscore n. This is just me so that I don't fool around with patch and patch 2. I'm just declaring this on the fly over here
as his method so that he doesn't override fast core methods patch and patch 2. Think of patch n as equivalent to patch and patch 2n as. Think of those as Rakel's methods,
yeah, exactly.
equivalent to the FastAI method. That's all that is.
Okay.
So here
Rakel's version of those methods, so that he doesn't, as he plays around with this code, he doesn't want to overwrite the original methods from the notebook. That's all.
Okay.
Okay.
The new Jeremy Club.
So cool, yeah. So looking at the one where you do as prop is equal to true, what I want to show, so looking at it, what should happen is we would come here, F in this case, it will be set to none. So why is f equal to none? I forgot. Does someone know why f is equal to none or f is not equal to none?
No.
What is the difference between this and this guy? Huh, okay, yeah, let's run through it and see. So let me just make these changes. Yeah, first let me play around like this. There's a couple of things that I want to show. Okay, cool. So patch is being called as prop is equal to true, height new. And so we come here and let's look at this. Okay. So in this instance, what is happening is that if we look at f happens to be none, which I forgot now why that is none. Oh, damn it. Why is it none? Is this none because it's a property and not a method?
I forgot.
Yeah,
Because
I lost the context of that too, but that's what it seems like, right? Because basically, but return partial of patch in
No, I
itself.
think I
No,
think
it's
he
just to
is
set the
right.
property thing. That's it. It's
Yep.
just setting the property as property.
no, true, but f is none in this instance. Like whereas in this case, when we passed it, we saw that f would be reshape.new. So that's why it never enters this, and it'll directly go create this class and return patch. So from what I figured out in this, just to give you guys an overview, is that so first time when it comes through, uh, f is none. It'll go into this, and then somehow it comes back in again, and then the f becomes height underscore new. That is the time it won't pass through this again, and it will be like the normal method case that we saw. That's why I showed you the method case first, because that's the one I could kind of track and understand. I really don't understand what is happening on the second one. 1 second, David, let me just show you what I was talking about, and then I'll let you guys kind of help me figure what happens. So like I was saying, that's why I was trying to print this guy up. So here, if you see, it prints patch underscore n twice. So it comes in here the first time, goes here. This partial, I kind of got confused. I thought partial was pretty straightforward in terms of use, but somehow it kind of redirects it back into this.
No, partial just sets up that and then calls it again, right?
Is the call also part of it? Like,
And is it a function of, again, I'm thinking because
let
I've
me go back to this.
what I say is not necessarily true. So double check, but can you check partial? So because partial just sets up and then.
Yeah, let's step through the code and see. David, did you want to say something before kind of step through, or? Okay, cool. Let's step through and see then if kind of things make sense. Let's figure this out. So we come in the first time, f is none, right? So we already saw that. Oops. So that means you will enter this case. When you enter here, you're creating this partial. And so basically you're saying for this function, which is nothing but this guy.
No, sorry. Also, how are we using it? Meaning you're using it as a decorator, right?
Yes, this is what it is, right? At patch. So
because
yeah,
I think
it is being used as the decorator here.
Because I think it also has to do with because it returns. What I'm thinking is if F9 returns, see, so it returns that.
Correct, that's what.
Which then gets called with the F, because if you look at his comment, he says decorator, add F to the first parameters class based on F's type annotation.
So it says add F to the first parameters class. Wait, don't understand what that means. Add f to the first parameters class. Okay, so the first parameter is basically whatever you're sending in as the first parameter, and that one's class you want to add f. Yeah, so that is what monkey patching is, right?
So monkey patching is just adding the method, not this another level of indirection of checking the type annotations, right?
I guess, yeah, the type annotation part is just to figure out what this class is, right? Otherwise, you
Yes.
won't know what the class is. So the type annotation is just enforcing that part. That's what I understand. Like, if you just send in X, you're not going to know what the type is. So you just annotate it, so then you know what this class of this first parameter is that you're sending in. So then you know that this X, or rather in this case, this X,
Yeah,
what
what
it
the
is.
type,
Correct.
and no, but you're attaching it to the class. I mean, this is where Python's the type and the class, the fact that classes are types makes the language very imprecise. But in this case, you're looking for the class of the type annotation, right?
Yeah, so that is image.image, right?
Right, right,
Right, yeah.
right.
So
But in the
basically,
typical monkey patching case, meaning forgetting about this patch, but patch 2, then you're just directly providing the class.
yeah,
You're not
okay. Yes,
deriving the class.
correct.
You get the class provided as a parameter to you.
You know the class already. Yeah, correct.
Right.
Right.
Right. In this case, you have to figure out the class.
Right. Yeah. Why? But that's what I don't understand. Why do we have to figure out the class, like for in this case?
Because you have to figure a bit from the type. You have to figure out the class.
No. So what
You
is
have
the
to figure
difference
out the
between?
class of the type annotation, right?
No, but that's the same here also, right? I'm kind of confused with the instance that we just saw now, where we didn't add it as an attribute, rather added it as a method. Whereas in this case, we are adding it as a property. So just
Right.
that.
But there are sorry, two separate things, right? One is what does patch and patch 2 do,
Right.
right? Versus as a property,
Correct.
whether you're adding it as a property or not. Because I think you can also, if I'm not mistaken, and I have been, we'll have to go back to the notebook to check. I recall that you can add it as a property to a class that you supply as a parameter.
Correct. Okay. So that is kind of when you jump,
Or
let us
as
say
a
you
class
already.
method. So it's independent. So you see what I'm trying to say is there's patch and patch 2 for a class that you supply as a parameter. Okay.
Patch, you can't supply a class.
For patch, you have just the class supplied as a parameter, and you can do as property and class method for the patch 2. Okay, which is the which is when you supply the class as a parameter.
Supply the class. So in both
Meaning
the cases,
you are explicit about the class.
Okay.
You don't derive it from the
right.
type.
So that basically means you're not talking about patch. You're just talking about patch 2 in that case.
Correct. And
Right.
there
Okay.
you can have as property and you can have class methods. See,
Correct.
those two are still available to you.
Right.
Okay.
Yeah.
So
that.
Right.
Now,
for patch, you always derive the class.
Correct.
From the type annotation.
Correct. Yes.
Okay.
Right.
And again, patch can be done with as property true and as class method true.
Correct.
Right. So
right.
That's at least, I mean, just to get that clarified.
Right. Right. Yeah, that makes sense. Like in most of the cases, I would kind of say that if you don't know what the class is, if you just kind of type annotate, where that's what you see in both these examples, you're trying to add something to image.image. In this case, you want to calculate the height. In this case, you want to use this method to reshape the image.
Correct.
And both of them basically use patch. Both of them are going to look at what your first parameters class is, and then basically attach this function and property to it. What I don't understand is in this instance, when we were trying to do The only difference I can see is like this as property is true is not set here. So that means as property is equal to false. In this case, what happens is when you enter patch, F is none. Shoot. When in this case, sorry, reshape is equal to new, when as property is equal to false, F is equal to reshape underscore new. And so that's why we never jumped into this loop. We straight away went, figured out what the class was, and we saw this part. This part we understand. But when you do as property is equal to true, it passes through this twice. The first time when it passes through F is none, it returns, it gets into this, it returns this partial. And then what happens is on the second pass, now you see that patch will actually be set to, F will already be set to height new. So F is equal to new, that's what we see now.
Yeah, let's step through it, but here's my take, because I saw similar setup. It's a function of the use of the decorator combined with partial, but let's step through it, and then I think we'll be able to figure that out. That
Cool. So here you see that the first time when it ran through F is equal to none, we've reached this partial. You hit this height new again, and then now you see F is none. And at this point of time, see the second time height is become new. And so it won't go through here. And then it behaves exactly like how the method height reshape.
So if F is none happens when you don't pass in anything to add patch in, correct?
When you don't pass this, I guess, yeah.
Yeah, so see, the thing is, he's using, again, I could be totally wrong, but I'll also spend some time on it if you can figure out by stepping through. But my understanding is when you don't, because what happens is he wants to use the add patch decorator with a parameter passed to it and use it also when no parameter is passed to it.
Correct.
Right. And when you want to use a decorator that way, then you have to play this if func, if the func that you pass in to the decorator, you have in one case is none and in the other case has a value. And that's what he is detecting. And then you go through that again.
You have these already set as default values, right? Like
but you don't call it with anything, right? In this instance, when you're calling add patch and decorator and passing in some value, right?
Yeah, I think to understand it, it would be nice to like break it up into steps, like decorator is done. Generally, it's simply like the first way, what decorator is shortcut to set in F equals to patch 2.
Correct.
Of F, you know?
Right.
So if we break it up into like this basic
nested structure.
Yeah,
I think there is also the what you say, you have already the values on if equal none and the asterisk. I think the important thing here is the asterisk, because you have your other parameters. So when you call patch in as prop true, F should be known already. So that is why it happens to be like that.
Oh, okay.
Because I am not so sure if the patch is like a partial when you have the at symbol, but maybe it is just setting. I will just pass here, and because F is equal none, it is like you keep the parameters up to that.
Cool. Yeah. So yeah, I'm not sure how to break this down. Do you guys want to try this now, or do you guys want to try it later? We are already like halfway through the class.
Yeah, we can each maybe try it offline and share what we find out.
Yeah.
Because I saw a similar structure that I was struggling with just last week of using, and as David said, like patch in, which is all set up so that at patch in it's being called and the default value is none. So if you just do add pattern and you don't have anything passed into it, then it goes into if f is none. But your question, which I don't off the top of my head have an answer for, is in which case it returns the first return, which is the partial of patch n as prop blah da 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 into the patch n, because it's a decorator call, right? So it's an at something. So it puts it back and then calls that. Now that's the part that can't explain off the top of my head of how that second call happens to make it go through the class and then return the patch to blah 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 of f, because by that time f is set to what you want as f, right? That's what is happening. So the thing that's happening is when you call add patch and you don't have this, then what is happening is it treats f as none because that's the default value. So nothing is set when you call it as add patch n without as prop is true passed to it. And that gets this partial call, which calls the patch n again, because that's what partial of patch n means. This, and that's why we'll also have to look at partial and see whether, that is a call to patch n just as that. And I think there it gets returned because it is a decorator. So
yeah, the weird thing is on this partial call also, patch n, basically you're calling this, and f is going to still be none, like at least in the terms of the call. As prop and class method, you're just passing through whatever you would have got. So this f, though it still looks like none in this, but after this suddenly did change to height new.
Not exactly.
No?
Maybe
Okay.
Let me try to walk through it like step by step as I understand it, to maybe try to summarize it in my head. So we want to use the one thing to notice here. We want to use it both and as directly as a decorator directly without parameters here. And also we want to be able to use it as a decorator with parameters. And when we use it as decorator with parameters, like in here, so we have a parameter as prop, then our patch n function should return a decorator. So it acts not like a decorator itself, but it returns a decorator, right? Here, when we call, so that's what happens. We first we call patch n with f equal to none and as prop equal to true, and we go to this pass when f is none. So when we pass this any parameter as prop or class method, so yeah, when we pass whatever parameter here, we will always end up with f equal to none, right? Because all of those parameters are keyword parameters.
Right. Okay. So wait 1 second. So that means you're saying if this is true or this is true or both are true.
If we pass any.
Correct. Yeah, that's what. If you pass, right. Yeah. This has to be none.
Yeah, we go. When you can pass it explicitly, but you don't do it, right? Because it makes no sense. Well, not makes no sense, but that would be like you would, if you want to use it as that decorator procedure, which I described, like f equal to patch n of f. You see, so when we pass as prop, or so when we pass keyword arguments here, we go to this pass when f is equal to none, and in this case we want it not to decorate our function, right? We don't want to patch f to the class because it's none right now. We want it to return a decorator. And that's what it does. It returns a partial of patch with parameters. And now it is a callable, which is a decorator itself. So in the case when f is none, patch returns a a decorator, which is used, and that would be the second call. You see? So what is this at patch n is? It basically
Arto has nailed it, I think, because that's the structure I was looking at earlier. So I think Arto's explanation is brilliant. Yes, that's what I failed to recollect, which is his key point he's mentioning is the fact that when you supply, I mean, basically you have this, as it is set up now, when f is none, you have or when you call it without any parameters, then yes, they are set as default, but in that case, you return a decorator. And in the other, right, which then subsequently in the next pass through gets the parameters. But if you have attributes, then it's a different, sorry, not attribute. If you pass it parameters.
Yeah, well, I have a question. Like, won't all these things be easier if you just remove this asterisk? Then you don't have to like check this f if it's none and go through the partial. Like, if that star in the argument is removed, and then f automatically doesn't become none anymore when you pass.
Yeah, but as Arto said, that wouldn't make, in this particular case, the most sense, right? Because you, his point is, you want to use,
like make.
Sorry, go ahead.
This, headaches, like those 2 lines of code that are highlighted now. Can you hear me? No.
Sorry, could you repeat?
Like losing the communication or something.
Hello.
I think I can't listen Tendo.
Yeah, I also can't.
Arto or
Tendo, yeah.
Can you hear me?
Yeah, I can hear you now, Tendo. Go ahead.
Oh, okay. No, Srinivas was saying something all of a sudden just broke up. I don't know.
So I think Tendo's point was, correct me if I'm wrong, like drop this and somehow be able to check just for the f is none and then kind of handle it with these 2 lines of code? Or was there something?
No, like mine is my idea, naive idea is like drop that asterisk,
right.
Yeah, and then
Lost you again, Tendo.
If f equals none, because when you're using a decorator, you most likely use a decorator for.
Sorry, Tendo, can't hear you. I don't know if it's only me or.
We can't hear. He's breaking up, or is
it looks like a connection problem.
Yeah, it looks like a connection problem.
But I think Arto, can you take another stab to take us through? I think your explanation is perfectly fits what is happening. So maybe you can re-summarize what you said, because I think
I was
that's
thinking
exactly
if
what
I could better explain it. So basically, what you can write, like there are 2 possible application of this patch and decorator, and the first would be you can define this. Like break it up into steps. First, can you like have a definition of height new function in one cell?
No, shoot. Sorry, 1 second.
Okay, good.
Cool. So what do you want me to do? Just define this in a cell?
Yeah.
Okay.
So now we in the next cell we want to decorate this image, like to use this decorator, and basically what this add syntax means is don't use add right now, just set height new equals to patch n of height new. Yeah, and let's see what it does.
This is basically replacement for this.
Yeah,
so
that would be like this is a classic
correct. Yeah. Okay.
application of decorator, right?
Yeah. Oh, sorry. Let me remove. Do you want me to remove the?
No, we can just skip.
Run through it. Okay. So yeah, so we are here.
Yeah. So we can just skip. You can press continue. And,
okay.
Yeah, you see, now we go to this
sorry.
line when we return. Yeah. So this is the first way we can go. And the second way would be like you should.
Sorry, 1 second. Is class already set in this case, you're saying?
I think it should. No, it just like we skip this if none part. We don't go in this direction. We go like in regular way. And now the second application would be if you type height new equals to patch n, and now let's add to some parameters to patch n.
Right. Okay. So I do that here.
First of all, we can add this. We can skip this if none line by adding. You can keep this height new as first parameter, which you pass.
Okay.
And then add this as property parameter, and you should remove the other. Good. So this time we go the same way, but we have like proper parameters here. And but if we want to use it in the same way, like a decorator here, so it should act. Basically, this is we do partial manually here, right? So
right.
That what it does automatically for us if we don't pass this height new function. Now you can replace height new, remove height new, and move it to the second argument.
Actually, I'm just going to copy this guy here and hold on to that. Okay, so this case, right?
Yeah, and now we should go to this pass when f is none. Yeah, and now it will basically return a function, which is a patch function with our keyword arguments, and now we call it. So basically, we it can be viewed as the same as our previous line, right?
So Arto, in this case, where is height new going through? Let me just change this to 1.
So height new is like this. We don't go to the this to moving. Yeah.
Can I do this? This should work, right? Still.
Yeah.
Okay.
Sure.
Okay. I just want to see what is the return function. So this is the case we're looking at. So f is none, like you said, and so go ahead. Yeah.
Yeah, I like your way to break it. So yeah, this return func would be basically a patch with some default parameters, right? And that's when it is called second time with height new.
Ah, okay.
So
because
first time
that
it is called with none and returns a function. In this case, it returns like a decorator,
okay,
but with a default parameters. And now this decorator is applied to height new,
which is the F in the last line of that, right? If you go up, this F that you see is height new passed to the patched thingy. And
right.
my understanding, Arto, correct me if I'm wrong, but my understanding of the way it is set up this way is so that you can use patch in as, or let me step back, so that you can use at patch in with or without giving in parameters, and it will work in both instances.
Yeah, I agree.
Okay,
so
and that's the thing.
One
You do not change the way you're calling, you just don't pass parameters or pass parameters, and in either case it will work. And to make the same structure
this if none
work,
line is basically done to take care of dealing properly with these parameters.
yeah, exactly. So that's the part that I was missing and that I struggled with earlier in the week. That's why this seems familiar. The point is, if you want to use a decorator with some parameters passed to it or no parameters, and as Arto rightly pointed out, this is the case where this at patch is actually either returning a decorator or returning with parameters set, or in the other case just returning the decorated function. Is that right?
Yeah, it's either applying parameter or decorator, apply decorator if the function is not none, or return a decorator if the function is none.
Yeah, that's what it's doing.
Cool. Okay. Yeah.
So I don't know if you guys can hear me now.
You're still kind of breaking up, Tendo.
Hello, I don't know if you guys can hear me.
Yeah, now you're better. Keep going.
Okay. What I was suggesting is like in the patch, if we go up to the patch, patch new, patch, and that place, yeah. Like, can't we just pass F as a normal positional argument and then remove the asterisks, then remove those lines 5 to 7, and then because on a normal, when you use a decorator is basically like a method that is supposed to wrap another method. Yeah, it always has an F, so I don't get why he's passing F as none in the first place, and then trying to like check it again.
Right, but that's exactly what Arto explained, right? You want to use the same setup, and just by passing it parameters or not passing it parameter, make it either return a decorator or return a decorated function. And you get that effect by the way he has coded it now. You can't get that effect in the way that you are describing it. But in the way, that's what Arto just explained. Maybe he can go over what he just explained very succinctly at the end one more time. So,
so I think I missed
that. To his words, Arto, please go ahead again, because I think you summarized it beautifully.
Okay, I will try to like make it clear. So patch new, this patch decorator is can be used in two ways. When it is called without arguments, it basically it applies a decorator to a function, right? But when it is called with an argument, for example, if we pass it as prop equals true, like here, it will not apply a decorator, but create a decorator which would be applied to a function later. So in this case, f is none, and the first time it is called with f equal to none, and in case when it's called with f equal to none, it creates a decorator which would be applied to this function at the second time it is called, right? So basically, this add patch syntaxes is itself calling a patch function. So patch is a function which is a decorator. And in this case, when we define our decorator with an argument, it is called twice. First time to create a decorator, and the second time by this add syntaxes to apply a decorator to a function.
Oh, okay.
Yeah, and
Sorry.
in the first instance, it is used to set up the parameters when you pass in a parameter.
Yeah, basically, you would have to have multiple decorators with like for sprop or class method for any combination of these parameters. If you want to have it like without this if none statement.
Structure.
And in this way, you can create basically multiple decorators depending on what arguments you pass to it. So that's like configurable decorator, right?
So I think I get that, but sorry, patch as with keyword arguments like this, like in our case, we're setting it as props equal to true. Why is it that the F is set as none? You know, I thought F was supposed to be height underscore new. Sorry if it has been discussed before. I'm just joining again. If you could explain why F in this case is set as none and not height underscore new when as props is equal to true.
Because as to explain, the first pass through that, you want to use the what Raquel has coded as red func to be a partial, which is again calling the patch n the same as Arto explained, the configurable part of the decorator you are now configuring it with asprop equals asprop.
Yeah, I get it now. I've seen it.
Yeah.
Sorry, I've seen it. Thank you. I've seen it.
Cool. Wow. Yeah, that was some 2 lines of code that took me a while to understand. Thanks.
Yeah,
guys.
no, I struggled with it just last week, so at least I know that Arto is right, and I still hadn't got it until he explained it a few times because I was struggling with exactly
it feels
similar
like
code.
Every time you need to understand it again, with this
I've actually studied this before.
No, I'm glad we discussed it at this much pain, because sometimes that's what it takes to recollect it when the next time you see it.
Yeah.
Yep. I hope. Yeah, I can recollect it. That's the.
No, you have to be hit on the head. I've solved this is my 3rd or 4th time struggling with the same construct, and I still hadn't got it. So hopefully this time I'll remember Arto's words and try to recollect what Arto said.
Yeah.
And see whether it sticks. But I'm sure I'll forget, and we'll have to, I'll have to go through it all over again.
Yeah, this recording probably, I'll have to save this segment out. Yeah, because I get the general idea, but yeah, I'm a little slow, so I have to probably look at it again to understand.
Okay, this is like the 3rd or 4th time I've seen the same code, and I still struggle with it.
I think the best way to understand it, to happen in the same situation when you need to define a decorator which behaves in different ways depending on how it's called, and then you will have to do this way, and then it will make a total sense to you.
I see. Okay.
Yeah, but that's the thing that I think, much like the class method, which is alternate constructor, I think the key I take away is configurable decorator, because it's basically this structure allows you to configure the decorator to use and combine it with partial to create the decorator with attributes, or use the same structure without any attributes.
Yeah.
Sorry, I keep saying attribute, without parameters.
Parameters, right?
Yeah. So it's this configurable decorator concept with different parameters and use a single setup.
Yep.
thanks, Ato. That was,
Yeah, thanks.
you're hammering it
Really
into us
explained it
was
Yep.
helpful.
yeah.
That was good. Okay, wow.
Okay, now you want to just do get atra, and then we'll go to L in the next lecture.
Yeah, we can look at get atra.
Sorry, by the way, was there anything else besides that you wanted to touch on patch and pattern, or that was it?
No, that was pretty much it. Yeah,
Okay.
that's for the first one was easy to explain. The second one, after the fix in F, I knew what was happening. Yeah, but before the fix in F, yeah, thanks to I'll kind of at least understand what is going on there. This is all just decorator stuff. Okay, I think set atra, everyone kind of knows what happens with set atra. There's nothing there special with that. Let's kind of look at this. This one I haven't done much work, but how much time do we have? Do you want to look at L, Srinivas, now and then some part of it?
Sure. Let me see how much we can get through, but at least.
Yeah, I mean, whichever, like break it in parts.
Yeah, maybe we'll at least get the setup.
Or if you want, I can, if everyone knows decorators, then probably no need of running through decorators in general. That's the only filler. I don't think I wanted to get at now because I myself haven't really pulled out
then
stuff.
Let's skip, because then we'll, I think it's valuable to spend some good time on it. Let me see how far we get through L, and if not, we'll restart there and go through it. It's not, and after the heavy lifting, it'll probably seem a lot simpler too.
And Rekal, do you mind sharing your notebook, please, on the chat?
Yeah, sure, we'll do that.
Thank you.
Yep.
Okay, hopefully, my only fear is that I'm not gotten disconnected. Can you folks see my screen? Let me know.
Not yet. Yeah, you can.
Okay, so maybe we'll do the helpers kind of stuff. Anyway, let's see around 50 or 55. Get me a heads up. If I go too late. So the L class is actually is used in a lot of places, and it itself is actually, let me point to that. Okay, it uses my apologies for scrolling badly, but okay, so it inherits from getatra, which we look at. I mean, we looked at the code, but examples we'll look at next week. A collection base, which probably we'll look at today, and then a meta class. Now, the details of the meta class, again, we looked at earlier, I think 4 or 5 lectures back, when we went through, I think, data loaders or type dispatch. But again, in the next walkthrough, which is the walkthrough 10, he goes through meta classes. So the details of the meta class I'll leave for a subsequent discussion, but I'll tell you what the underscore L meta, which he uses here, what he uses it for. Okay, and then we'll go through the code of L and the tests of L potentially next time if we run out of time. So collection base or call base is something that L inherits from. And so collection base is nothing but a simple base class for composing a list of items. So it just composes items that you pass into it and delegates to the list function or whatever you use. So for example, whatever items that in collection base you get are stored in self.items, and then you just, if you pass in a list, then it stores the list, returns the length. This is, get item, set item, delete item standard, meaning that if you have k, then you returns self.items of list of k if, again, k itself is a collection. Otherwise, it just self.items of k, right? Because if k itself is a collection, then you want to do a list of k because it's a collection, or if it's a collection-based class. And then if itself, same thing when you're setting. So this is the get item, set item, delete item equivalents. A wrapper is just delegating to the wrapper of whatever you pass into items. So if it's a list, it uses the list wrapper and so on. And this also is consistent with what I think Raquel pointed out, that if you have a choice between doing a wrapper or a string for a class, do a wrapper, because anyway, string, if it doesn't exist, delegates to a wrapper. Then the iter just returns an iterator, returns the values of self.items. So that's all that a base collection is. It just composes a collection. Okay. So you can just see what happens by the test he uses. So he just says, let's say this is a collection base, is just that, and you create an instance and you pass in a list. So the list is what is stored in self.items. So when you do the list of L, that'll be 5. L of -1, which is the last item, is 5. L of 2, it's at the index, that's 3. You set it as 100 and then test it to be 100. Delete the 0th item, so then the length becomes 4, and you convert to a string. Then because you have set the 100, then it becomes 20045. Okay, so that's that in so far as testing a collection base, because that's just a simple collection. So now instead, the meta class. So I'll try and explain, and it will absolutely not be sufficient, because again, this meta class, like decorators, is we need to spend quite some time on it, and we will spend it in the next lecture as part of the next lecture. But here, I'll just tell you what the meta class is used for in creating the L class. So this meta class, because what it's doing is it's changing the call of the class L. So the meta class is something which is used to change the behavior of a class. So that's what a meta class is. Just like a class creates instances, a meta class changes the nature of the classes that is created using the meta class. So in this case, what it does is it changes the call of the meta class, which creates L. So the L call says if not these, and if X is also not none, meaning you have values for this, and if X is an instance of a class, you return X. The point being that, as we'll see later on, the thing he wants to do by use of this meta class is, if you call an L from an L, it actually returns the L and not a copy. So it gives you back what you started with. So analogous explanation would be like in-place modification of like a data frame and stuff, instead of creating a copy. So instead of returning another list, it actually returns the same L. And we'll see in a test that it checks that it's exact. So this will be a case where L1 is L will pass, because it's exactly pointing to the same thing. It's not L1 equals L, or it's not just a point, a pointer. It is exactly the same object. Okay, and we'll see that, and we'll see how that meta class works, as I mentioned subsequently. So before we go into all of this code and details and things like that, maybe what I'll do is use the time to just, he anyways points you to a very brief kind of some simple write-up he uses, and maybe we can just very quickly look at it and then start the rest of the discussion of the class and various tests he uses, which is how he even begins to explain all the various cases why he does the L, but instead of using a standard list. But let's look at this very simple explanation of L, which I think is very brief because there's a lot more to it and we'll dive into the details, but let's just go through this part and maybe end right there, break up there and start next week with the details. So here he's just saying that, you know, instead of using a he wants to use a very compressed syntax for something that you use very often. So it's just a single word syntax because you just type capital L, blah, 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 because you tend to use it very often. So you want to reduce the class and make it a class that has a single letter name like L, right? Because it's a replacement for a list and we want it to be as easy to use as 1, 2, 3. So you pass it any kind of iterable and it will return you the number of values in it and the list, or at least, you know, this will be the wrapper printout of L of 1, 2, 3. So when you call it, it will have a representation of its elements and it will tell you the length of L, right? So it will show you its number of elements. And so if you, for example, say range of, and like I said, you can pass it multiple things. You can pass it a range, you can pass it, I think pretty much any iterable. And so in this case, 20, and you call a shuffle on it and out comes, hey, there are 20 elements. And it gives you, I think this is configurable, how many elements it prints, and then a dot, 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 because it doesn't print all of the elements in every instance if the number of elements is very large. The other thing that's very useful, which list doesn't allow you to do, is it has the indexing ideas like a NumPy array, which means you can use an L to index into another L. And so L contains many of the same indexing ideas. So you can do P246 and it will give you the index into P, right? And the other cool thing is it does like NumPy array, you can use L.argware. So L.argware, I mean, it kind of is self-explanatory. You can see P dot, so P is L. So you can do P.argware. And again, this he gets into in a minute. You can just say GE15, which means greater than or equal to 15. So give me the indices. So this is translated as, give me the indices where the values of P are greater than 15. So obviously 18 is 1, 16 is 1. So you'll see 0. And I'm assuming this is at index 7. 0, 1, 2, 3, 4, 5, 6, 7. Yeah. And then, you know, obviously the rest of the numbers are here. And these. So you need to remember that this, what it returns when you use an argware is the indices, not the value. But you can't do this with a list. Right, so he has added the argware argument, or the argware method to L, right? So what he is pointing out here is that the FastCore includes a number of features that makes a functional style of programming, and supports a bunch of things like this G, LE, GT, things like that. So you can just say G15, which is greater than or equal to, GT is greater than, which gives the same answer as the functions. And the cool thing is, in order to do this, if you were to use any kind of a list, even forgetting the indices stuff, you would have to do operator, you'd use Python's operator function, operator dot, and I think there are multiple operator dot, greater than, less than, blah, blah, blah. Right. And then if, yeah, if given, so the other thing he has done is it gives the same answer as the functions from the Python's operator module if given 2 parameters, but returns a curried function if given 1 parameter. So curried function, what is a curried function? Maybe, you know, I'm a self-taught programmer, so I haven't gone through the details. If somebody wants to explain briefly what a curried function is, but this is the Wikipedia link, which basically says that you can break up a function and call it in sequence. And so each of them becomes like a single parameter value that you pass to it, and then becomes the final X. And that's part of this functional programming languages and paradigm. Right, and as he says, it's currying is kind of like, but it's not the same as partial, right? Because partial, you set some parameters and call it. Here, it break up the function into a sequence of function, each parameter called by itself, and then pass to the next in line. Any comments on curried function?
Yeah.
Anybody
Is
wants
it like
to share?
kind of like a pipeline? Yeah.
Yeah. Yes. And then there's a bunch of functionality that we will get into in the next lecture next Sunday, but we'll go through that. One of the cool things that it allows you to do that list doesn't is add from the left or append from the left. So when you do 1 plus L234, it'll become 1234. You cannot do this with a list. With a Python list. So, and we'll look at, I think we touched on the most important things, but of where an L is, but there are many more. But I think the most important ones are that L returns an L, and L uses, you can use indexing of L within an L. You can also, one other thing which he doesn't touch on is L as he's apt to do for almost many things like cycle and a bunch of other stuff, is also coded to support nuns in many cases, whereas your list doesn't. So that's something else that an L does, as we'll see. And yeah, so the keys are that L returns an L. You can use an L to index from an L to another L. You can use the NumPy array type of arguments. You can use this curried function type of things inside, and you can append from the left. That's kind of very brief because there's a lot more to it, but we'll, instead of breaking up in the middle, let's, I think, maybe give people a 15-minute break, so we let the decorator knowledge we attained today percolate into our brains, and we'll start with, you know, all the code of L and the testing of L and so on and so forth next week. And we'll start with that and then get into getAtra. Also, Rekli, if you have time, maybe you can even look at, you know, some interesting L use cases if you find them, because that would be, you know.
Yeah, I'll keep an eye out for that. I was thinking of getAtra and delegates next time.
Yeah, delegates, we haven't covered the code though.
Oh, I see. Okay.
Because delegates, he hasn't gone through the code yet.
So
we haven't gone through delegates code yet.
Okay, so cool. So getAtra and L then.
Yeah.
Sounds good.
Okay, so let's stop here, since that will give us, I think, next week, cover the rest of L and getAtra and L usage. And we'll take a break before people joining the hands-on machine learning class. Okay, thanks a lot, Rachel. Thanks, Arto. That was very helpful and useful. And we'll get through L, and at that point, we'll also be able to start on the last lecture of last walkthrough, where he covers meta classes, and there are many more notebooks in FastCore that he goes through. We have just, in fact, covered 2 of them, test and foundations.
Yeah, thank you both. Great stuff here.
Yeah, this was really helpful today. Since we have some time,
thank you.
quick question for everyone. Since we're going to be, what do you think, Srinivas? Maybe 1 or 2 more sessions?
It may be 3 or 4 because, but at most though, because depending on how much. Because as we get into meta classes and stuff, then there is the same thing like we did today, right? I mean, even though it wasn't planned, we really dove into configurable decorator. So that kind of stuff, because we don't, he gets into things which aren't used, but which are very useful to absorb. So max 4, but it will come to an end. So your question is still relevant of what to do next.
Yeah, I have a suggestion that we continue doing this, but just each of us pick like different pieces of code from FastCode or FastAI and kind of just dig deeper.
Yeah, that would be great. I in fact, the one thing which Jeremy didn't do, which I really wish people would try, I am obviously willing to try as well, is go through some of the
learner stuff is
callbacks, not just the history, but how do you what's the term for where he hooks, right? Hooks, callbacks, configuration of the learner, the whole training loop, all of that kind of stuff, which he covered in an earlier version, but he hasn't, but after that, even FastCore is, Rekil has been pointing out, has been changing so fast. So I'm sure he made a ton of changes in callbacks and other stuff as part of part 2, which we haven't gone through at all.
Yeah, I suggest, we keep this time slot for this.
Yeah, that'd be great.
Sounds good.
Sounds good.
All right, thanks, guys.